Hello, this is Malachi Bishop, and this is section 2 of week 4. And in this section, we'll be talking about the next step in our research process. We've talked about research questions and hypotheses, research designs, variables, and methods for measuring the variables. And now we will be talking about best way to sample a population to answer your research questions. So sampling, the question is, what is the best way to answer my question or to test my hypothesis? And the answer is to measure or assess the issue among the population. Unfortunately, populations are often too large, too inaccessible, or unwilling to participate. So in reality, what we do is we take a sample. We select a number of subjects or participants from the population. And ideally, if everything goes right, the results that we get from the sample will tell us what we want to know about the population. We'll be able to say that the results generalize to the larger population. So some sampling issues. If our goal is to make valid generalizations about the population, or to have a true accounting of the reality within the population. What is the situation within the population? How can we achieve this as researchers? And what characteristics of the sample allow us to have confidence that our sample is representative? How big of a sample do we need to ensure that the findings will generalize to that larger population? And generally the answer is as large as possible. The larger the sample, the more generalizable our results will be. Larger samples reduce the chance of random sampling error, or in other words, getting a sample that doesn't resemble the population, and large enough to account for extremes in the population, large enough to account for all of the variables that we are interested in looking at in the population. So you can see if we have too narrow or too small of a sample, frequently we will not achieve the goal of a representative sample. So ideally, in general, the larger the sample, the better. So regarding sample size, the selection of the sample size will depend on a number of factors. We said we want it to be as large as possible. But other issues include the statistical tests that we want to run and the research design, among other issues that we'll discuss later. But just to look at a couple of examples where the statistical test that we want to use comes into play. To do a correlation analysis, for example, it's generally recommended that you have a sample of at least 30 participants. For multiple regression analysis and other methods that are similar, it is recommended that there be between 10 and 20 subjects per variable, per independent variable. And the reason for that we'll talk about later. But it gives you a sense of if you have a project where you are wanting to measure. Let's say you're doing a project looking at vocational rehabilitation outcomes, and you want to consider the effects of gender, income, ethnicity, maybe a part of town they live in, or whether they live in an rural or an urban area. We can come up with a few more, maybe age. That's 5 we've come up with already. So already we're talking about a sample of between 50 and 100 subjects. So sometimes in cases like that, the statistical test that you want to use affects the sample size that you're going to need. And we will talk more about that issue when we talk about inferential statistics in a couple weeks. Now let's talk about methods of sampling. In random sampling, the sample is selected in such a way that every member of the population has an equal and independent chance of being picked. We usually use random number tables for this process, and you can find those on, you can actually just search for them on the internet, and you'll get a bunch of tables that are just tables of random numbers, and you can use an approach like that for picking random numbers for random sampling. And random sampling is the best approach for ensuring that the sample that you select represents the population. So that's the ideal approach. And the idea of independence there, I said every member of the population has an equal and independent chance of being picked. What that means is if I'm sampling from a class of 30 people, let's say, and I'm going to do a random sample of 10 people. So I'm going to pick from that group of 30 people. Everyone in the class has a 1 in 30 chance of being selected, right? Once I've selected a name from my hat there, the selection of that person has changed the odds for everybody else. So now you have a 1 in 29 chance in being selected, which is slightly different. So in random sampling, I actually have to put that name back in the hat, and in that way every member will have an equal and independent chance of being picked. So that's the idea there. In reality though, simple random sampling is rarely used in research, especially when we're talking about research where we're actually going to have to interact with people personally for doing things like interviewing. And the reasons we'll look at in a minute why that frequently is just not practical. So there are some variations on simple random sampling that we use in research, including systematic sampling, stratified sampling, cluster sampling, and convenience sampling. First of all, systematic sampling. And this can be used when the members of the population are known. So let's say, for example, there are 100 CRC, Certified Rehabilitation Counselors, in the state of Kentucky. And I can identify them, and I want to sample, let's say, 10 of them. All right? So we could use the systematic sampling approach. And I'm going to read this sort of confusing sentence, and then we'll talk through what it means. The population, N, is divided by the desired sample size, small n, and then a randomly selected number, represented with a k, of between 1 and the number of the sample size, n, is chosen as the starting point. And from that number, every kth element is chosen until the desired sample size is reached. So what does that mean? It means if I want a sample of 10 from the known population of 100 CRCs in Kentucky, I would select a random number. So here's where the randomization comes in. I would select a random number between 1 and the size of my sample, which is 10. So let's say I randomly selected the number 3. I would line up all the names of the CRCs in Kentucky, or I would, if I have a number for each of them, I would line up those numbers from 1 to 100. And I would, beginning with number 3, because that's the random number that we selected, I would take the third person, and then I would take every third person until I had selected my sample of 10 people. So the sample would be number 3, number 6, number 9, number 12, and so on until we got to 30 and we had 10 people. This is a useful approach, but it sometimes is associated with problems. You can see, for example, if we're talking about 100 people and we only got to 30 in our sample, then there's a whole lot of people at the other end of the spectrum between 30 and 100 who weren't included in the sample. And when you think about things like using zip codes or last names, and if those sorts of things have some relationship with characteristics of the people, like let's say people with higher zip codes happen to live in a region of the country, region of the state that makes them unique or different from everybody else, and it would be important to include them. we just excluded them by only taking people from the first third of the population. So sometimes you have issues like that, but this is a useful method, systematic sampling. Another method, stratified sampling, allows the researcher to be sure that subgroups are represented within the sample. And a lot of times researchers developing standardized tests will use stratified sampling. And the idea here is you want to, let's say you have a population with specific groups within it that are divided in strata. So let's say, for example, people from different minority backgrounds. And what you do is you try and achieve a sample where the number of people in your sample is matched with the number of people or the percentage of people in the population of that background or within that strata. So let's say, for example, I'm developing an intelligence test, and I want my norm sample to represent the population with respect to minority background. And I know that there are, let's say, 20% of the people in the population I'm concerned with are from an African American background. Then if there are 20% in the population, then I would, from the population of people who are African American, I would select 20% of my sample randomly. All right, so that way I know that just like the population has 20% African Americans, my sample is also going to be 20% African American. So that's a useful method if you want to make sure that specific groups within the population are represented in your sample. And then finally, cluster sampling, where the unit of sampling is a naturally occurring group rather than an individual. And it can be a geographic group or a school or something like that, but it's a naturally occurring group rather than a single person. We still do random selection, but we use this method when it's more practical or feasible to select groups from a population of groups than individuals. And let's look at an example of when that might be the case. This is a map of Kentucky with our many counties within it. Let's say I was wanting to interview 300 rehabilitation counseling clients in the state of Kentucky. And if I did a random sample of 300 clients and I was going to meet with them all face to face to do an interview, I would be going all over the state randomly, right? So instead, maybe I would randomly select 10 counties and then interview groups of clients, 30 consumers in each of those 10 counties, and that way I would get my sample of 300, but I would only have to go to 10 rather than the 125 or something counties in Kentucky to talk with them all. So that's a very useful approach, cluster sampling. And then finally, convenience sampling, which you're familiar with that idea, I'm sure. It basically means using the group of participants that are convenient to you, easily accessible participants. And we talked about that approach when we talked about qualitative sampling.